Hello, gents, and welcome to my humble workshop. Um, so, me and the wife, we went antiquing over the weekend and happened to notice this radio receiver and couldn't pass it up. So, did some research on it and come to find out that it is from 1946. It is a Clarion model C104, and I've already had it plugged in on my power supply, and it actually somewhat works 77 years later. So it's a bit surprising, but yeah, they made stuff dependable back in the day. They didn't want it to just go to the landfill after the warranty's out. So I wish we could get back to that maybe at some point as a society, but yeah, it doesn't look like that's going to happen anytime soon. Anyway, a man can dream. So yeah, so I was gonna check some resistors in this thing and start off with that. That's a good way to kill time while I'm waiting on parts or other things. So um, wanted to show you guys how to check resistors to see if they're okay or not. So we'll start with this one right here. And I'm gonna test most of these in circuit. Now you can't always do that, um, but most of the time with vacuum tube equipment, you can get away with it. And the reason why is that tubes are very high impedance devices. They're and compared to like transistors and FETs, they're very high impedance devices. So a lot of the times you're okay to actually check resistors in circuit. Whereas if this is solid state, it would be recommended to solder this end out and lift it up and then check it while it's hanging in the air. You don't necessarily have to do that with tube equipment. So we're just going to try to do it the lazy way and check them in circuit. So getting down to brass tacks here, the way that you tell what a resistor value is there's a color code. It's like the rainbow. And so it starts out at black, and black is the code for 0. And then it moves to brown. Brown is the code for 1. And then red is the code for 2. Orange is 3. Yellow is 4. Green is 5. And blue is 6. 7 is like this puke color. It's pretty ugly color. 8 is gray, and then I believe that 9 is white, but you don't see 9 that often. Usually 9's pretty rare to see. So looking at that, knowing this, knowing our color code now, what you do is you start at the one that's closest to the end, so this brown stripe. Now this brown stripe will tell you the most significant digit of the number, the value that this thing should be. And the next stripe will tell you the next most significant digit. And then sometimes there's actually 4 stripes instead of 3. So I'll grab like a modern resistor here. I don't know if it's going to focus on that. You see there's 4 bands, and one is called a tolerance band. And that lets you know that you can expect the resistance to be within a certain range. That's all that is. But sometimes they can even have 5, and if they have 5, then the third one is the third most significant digit. Basically, the last one before the tolerance band is your placeholder, and it lets you know how many zeros you need to add at the end of whatever number you have here with these 2 bands. So this would be 1 0 and then 2 zeros tacked on to the end. So this should be a 1K ohm resistor or a 1000 ohm resistor. So let's check that with our meter here. Let me zoom out a good ways. Apologies, I can't get both in the camera at the same time, but we'll see what we have. So that is 1.132K, so 1131 ohms. Pretty close. And the good thing about like analog equipment like this is that the resistance doesn't have to be spot on. Very rarely does it need to be like exactly or close to what it says. A lot of the times you can get away with it. So let's try this one right here. So it's kind of hard to see, but that's a brown band on the very end, and then black, and then yellow. So yellow is 4. So this is going to be brown is 1, black is 0, yellow is 4. So 1, 0, and then you tack 4 extra zeros onto that. So this should be a 100k ohm resistor. All right. Turn the light on there. So let's see what we've got. 89.3k ohms. All right. So that's probably okay. I don't know exactly what that resistor does, but I would say that it'll be fine. Let's check this one right here. So what should it be? That is red, black, and yellow. So 2, 0, and 4 zeros. So this one should be 200k. Let's try that. Not reading anything. Make sure it's not a bad connection. Still nothing. Let me try my range. Go to the megohm range. Still nothing, man. Okay. Maybe it is just open. Let's try hitting the range again. Nothing. K ohm, nothing. Okay, so what we can do is find a larger resistor than that. There's probably, let's see. There's a 500k right there. That's good. Or no, not right there, right here. Sorry. So let me get this in the camera a little bit better. Let me move this. Support everything. So green, black, yellow. So 5, 0, and then 4 zeros. I'm gonna move my meter over here, zoom out, and let's try that. Let me try to do it without blocking my meter. Let's try, leave that one there, change the range. Okay. 480k. So we should be able to read this 200 at that point. All right, so let's try it. Still nothing, dude. So maybe that thing really is just open. I would say it is. I could try to lift it out, but usually if there is something in parallel, like the reason you can't check stuff in circuit with most equipment is that there'll be other things in parallel with it, and your meter will see those other branches of the circuit. And anytime you have a parallel circuit, the resistance will be lower than it would be if it was just one element. So generally speaking, if you check something in circuit, if anything, the value that you get will be lower if you do happen to catch something else that's in parallel. So pretty confident that guy's bad and it's going to need to come out. I wonder what wattage it is, because that's one thing you really have to pay attention to with resistors is looking at their power dissipation and choosing a resistor that has a sufficient wattage rating to handle that, because otherwise it'll get really hot. Resistors dissipate energy as heat, so they can overload and go open, or sometimes they can fail shorted. I've seen that as well. Let's see. There's one here. Is there any in the camera that I haven't checked? There's actually a 500. Yeah, there's a 500k back there. That's a higher wattage resistor. It's bigger than the others, so let's try it. Okay, let me zoom out so you can see the meter again. There we go. $555. That's probably just fine. I've tried that one. No, I haven't tried that 100k. There's one over here that's 100k as well. Not picking it up on that range, so let's go to k ohms. Not picking it up there either. Let's try the mega ohms then. There we go. 90. Okay, so 90k. I wonder why I didn't pick up on the k ohm. Oh well. 150, or no, 151, so that'd be 150. Let's get out of that mega ohm range. back to there. 144.5. Nice. Very good. It looks like that's the only one. I don't see any others that I haven't checked. Actually, no. There's another 200K right there. Let's hit it. Keep going up. 190K. Very good, very good. 100K right here. 88.4. Can't remember if I checked that one or not. So this one, 2. I don't wonder what that one is. That's a little weird looking. 46. There might be something in parallel with that, because it should definitely start with 2, whatever it is. Don't really see much in parallel other than this capacitor, but my meter shouldn't see this capacitor because it's DC that it's applying across it. Oh, maybe the IF transformer, but that would make it be lower. So that one's probably drifted, I would say. Yeah, if you guys like these kind of videos, I love troubleshooting stuff and the logic of it all and blah blah blah. Yeah, if you guys like that, just let me know. If there's anything I can improve on, I'm open to that as well. I know the camera work's a bit shoddy, but I'm still just getting into this as a hobby, so just bear with me. I love you guys. Mwah.